this segment will introduce some tips for how to read your ECG data and how to interpret the data. So it's important as you go through this sequence of labs to start to get a sense, kind of an intuitive sense of what is a normal value. So if somebody asked you after you've gone through this class, what's a normal value for heart, for ECG? Well, first thing you'd have to ask is, what aspect of the ECG? The raw ECG is measured in millivolts. It's just literally showing the amount of voltage it's being picked up at the surface of the skin that is emanating from the heart. So first thing you need to ask is, what aspect of the heart are we measuring? So heart rate, that's a typical one. Most people have a little bit of a sense of heart rate. So you might already have some intuitive sense of this. Somewhere between maybe 60 and 100 would be a normal range for a normal person. But then in comes the unit issue, 60 to 100 watts. So you need to have a sense of that. What are we measuring? 60 to 100 watts. So that's the number. Unit, this is again where unit is important. You just scribble down 60 to 100 and you haven't specified 60 to 100 watts, beats per minute. So I think most people kind of have a sense of this as well. Maybe you've even taken your pulse, trying to figure out what your heart rate is. It's kind of a helpful number. This 60 beats per minute is a helpful number because there's 60 seconds per minute. So if you needed to conceptualize it down to the second level, you could actually do it. That corresponds to about 1 beat per second. So heart rate is kind of a nice feature. It's something we can have a very intuitive sense of because we have a sense of what a second is. Now, if it was 100 beats per minute, that would be 1.2 beats per second, 1.6 beats per second, excuse me. So again, that's something to have an intuitive sense of. It's more than 1.5 beats in a single second. Now, if you flip that around, you can ask, how much time does it take between beats for one full cardiac cycle? That's a fancy word for heartbeat. Time for a heartbeat between one heartbeat to the next. So at 60 to 100 beats per minute, if you flip that the other way around, it would be about 1 second for a heartbeat for that 60. Or if you're talking about 100 beats per minute, that flips over to about 6/10 of a second, and we're talking seconds here, 6/10 of a second from one beat to the next. So this scale shrinks as the heart rate increases. So it's important to know. And in a lot of the psychophysiology that we do in the mind-body lab, we're actually looking more at that time for a heartbeat. It's called interbeat interval is the fancy word for it. And then here's a whole other thing to measure about the heart, which is blood pressure. And this is something we also have kind of an intuitive sense. We've heard about 120/80. That's maybe a normal blood pressure. And so what can get confusing here is those numbers are all kind of in the ballpark from each other. 120 is close enough to 100 and 80 is close enough to 60. So it's easy to kind of blur all that together in your mind and think, oh yeah, the heart stuff is somewhere around maybe 80 is kind of good average. But blood pressure, if you think about it, what is the unit of measure for blood pressure? Is it beats per minute? Is it seconds? It's actually millimeters of mercury, which is just a kind of a measure of that pressure at that moment. And mercury became, there's a whole historical reason why mercury became a way of measuring it. But that's like a whole other scale. So it's just kind of a coincidence that blood pressure values in the normal range have similar sounding numbers to heart rate in the normal range. But this is kind of a good example of why knowing your units is really important, because you just throw out the number 80 about the heart and think that somebody's going to know what you're talking about, and really you have to be more precise than that. Now, if we dig a little bit deeper in the time for a heartbeat category here, then we can split it up between systole and diastole. And so, as we saw in an earlier video, between the two of them, they add up to the full time for a heartbeat, the full cardiac cycle. But it's interesting to see kind of some normal values for systole and diastole. It's systole is 0.2 to 0.3 or 2 to 3 tenths of a second is usually the amount of time. It's kind of normal for systole. And then diastole can also start around 0.2, but it can go much longer to 0.7. So there's a wider range of time that typically is taken up in diastole on average than systole, but not always. They can both be around 0.2 of a second. So when we think about normal values, again, we have the beats per minute, 60 to 100, and the time for a heartbeat, 1 to 0.6 of a second. But if we flip it around, 0.6 of a second to 1, we're just putting that in kind of chronological order. You need to remember that the 0.6 of a second maps to that 100 beats per minute, and the 1 second maps to the 60 beats per minute. So it's kind of important to just kind of have a really good intuitive sense here. Okay, changing gears a tiny bit. As you're reading your electrocardiogram, it's going to show you a channel that shows ECG, okay? And this is in millivolts. This is actually how much electricity is coming out of the heart and being received at the surface of the skin at that point. Then there's, down below it is the heart rate, which again, challenge you, should be measured in beats per minute. Now, there's something interesting going on with this, and you will see this guaranteed in your data as well. We got the first second of data here. Again, this x-axis is always time. And the heart rate starts out, the heart rate kind of record here. This is the very beginning where you first started collecting your data. The heart rate is down, and if we kind of follow this along, the heart rate is showing as 0 beats per minute. And so you're like, oh my God, I was flatlining. And then somewhere along the way, then all of a sudden, at around 1 second, suddenly I get a signal that's kind of normal. It's like 80 or something like that. I guarantee you're going to see this. You do for every person. And I'm challenging you for a second to think about why would my heart rate show at 0 for that first second? Well, it turns out, so why is it flatlining here? What's really going on is to get a rate, beats per minute, you can't get a rate off of one beat, one single beat, because you don't know how much time elapsed to the second beat. The only way you're going to get a rate is you need a minimum of 2 beats. And from there, then the system will calculate, well, if I did at a rate of however many seconds this was, maybe it was 0.8 of a second, I can flip that on its head and say how many beats per minute would that be, and then it would give you a number and you get your, whatever it is, 80 or whatever. So this is super important to recognize. What's important also is when it asks you to calculate the rate, and you're going to be highlighting here somewhere to get a rate and reporting it down in your lab report, don't make the mistake of highlighting the very first second. And I find the lab report is often misleading and says start at the beginning and start calculating your heart rate. Well, don't start at the very beginning, because you're guaranteed going to get a 0 until your second beat shows up in the record, and then it can start calculating a rate. Last point of reference is you're doing your ECG lab. Don't try to diagnose yourself. It really takes a medical professional, and it's way beyond the scope of my knowledge, to be able to look at the various beats and the various patterns and somehow to say, oh, this is indicative of some cardiac condition. Most likely any kind of aberrant looking things are going to have to do with you being an amateur and running your first electrocardiogram. So don't be worried if it looks like you're flatlining, because again, that's just like a fact of kind of an artifact of the data, etc.